Hello, everyone. Thank you for joining our webinar. This is already our fourth webinar this week from our webinar week. This afternoon, we are going to be talking about how significant the 3D printing affects our logistics, and how the 3D printing, for example, from PEEK parts are so strong as metal. And this is a webinar in cooperation with Roboze, and I will be your speaker for today. My name is Philip Binkert. I'm an executive director at 3D Model. I've been in the 3D printing business for over 10 years now, yeah, I remember back in the day when 3D printing was at its very early stages. And I'm very excited to have Graham Lindsay on board, in charge of sales from Roboze. So he will also be joining the discussion and presentation. So very excited. This webinar will be is being recorded. So if you wish, we can always send the recordings out to you. If you have questions, feel free to write them in the Q&A section, and we will get to the questions at the end. So again, thank you. And to start off this discussion, nowadays we have so many printers and printing technologies out there that that makes it very difficult to choose what is the right printer for me. Not only different technologies, we have a wide range of printers in different price categories, from low price segment to very high price segment. Furthermore, we have printers for prototyping, for manufacturing, and to make this more complicated, we have a huge wide range of materials. So not only that there's a new 3D printer coming on the market every month or every 2 months, we also have new materials that are coming almost every day, a new material for a printer. And as we know, not one 3D printer can print all materials. So if we go online, if we try to read about which printer is the right one, it gets confusing. And while we're presenting and presenting what Roboze can offer you, it is important to see how do I start? How do I look for the right printer for me? Right? What is the correct way to go about it? And therefore, I would start asking myself questions. What are my needs? And the first question what I would propose is, do I need a 3D printer for prototyping or functional prototyping, or is it for manufacturing, or is it both? In this sense, I have to start defining my application, right? If I'm in the area of prototyping, right, then I want to do maybe quick runs. I want to do the first testing and then print more. I will go through several iterations, right? Or are these prototypings going to do the first testing? Right, so then I do need more special material. I have more demands on my printer. Or do I need a printer for the manufacturing? I want a printer that I can build parts, build it into my rest of my components, that it works for a long time, that it holds the elements All right, I need strong parts. So it's very important to define which application that I'm looking for. The second question is material. As I said, there are many different types of materials, and that alone can get very confusing. Today we have different types of plastic, ABS, PLA, nylon. We have flexible material. We also have metal and many different types of metals, from titanium, cobalt chrome, copper, stainless steel, and furthermore material in the metal area. Also, we have ceramic. So what is the correct material that I need for my application? The third question I would ask is, what build volume do I need? Do I have small parts? Do I have big parts? Or do I have many small parts? Or do I have to do a lot of iterations? So I have maybe just, when I just print, if my demands are just small prints, and I have a low volume, then of course a standard format would be enough. But if I have many iterations that I need to print at the same time, then we would go to a large format. Or do I start thinking about building up a print farm? So I would start asking definitely these three questions. And the fourth question is budget. What am I willing to invest? Am I starting off? Am I starting with the 3D printing, or am I already an experienced user? So it also defines, again, comes back to the first question, to also, again, prototyping and manufacturing. What am I willing to invest? Also, depending on my return of investment. So a 3D model with our locations in Switzerland and Zurich and in south of Germany, we have a wide range of manufacturers, of printers and technologies that we can offer. Alone in a prototyping and functional prototyping, here we have, for example, Markforged, 3D Systems, Formlabs, and of course, Roboze. And with this wide range, we have also a wide range of materials. And of course, we definitely have a solution that fits your budget. And today we're going to talk about what Roboze has to offer. They have high quality, high-end material, plastic, from nylon, carbon nylon, PEEK, and carbon PEEK. So it's very interesting to see what they can offer. As well, in the manufacturing, if I need end-use parts, right? It doesn't stop there. We have also here solutions, and I will highlight again the Roboze, right? We don't always need metal, right? We can nowadays replace, for certain applications, we can replace the metal with the high-end plastic that is most of the time easier to work with. So with that said, I will be handing it over to Graham. So again, welcome on board, Graham. Thank you for taking the time in your busy schedule to present in the offerings of what Roboze has. Thank you. So I'll stop my screen, Graham, when
you can stop your screen. Yeah, I can hear you, Philip. Yeah, no problem. Okay. I've picked it up for me to share. So you should now see my screen.
Yes.
Yep. Okay. I will start my part of the presentation. Unfortunately, it started at the beginning, so let me just flick through till we get to the part that's right. So, okay, so welcome everybody. My name is Graham Lindsay. I work for Roboze. I'm the VP of Sales there, and thank you for joining us today. So the subject I'm going to talk about is really the evolution of the supply chain. The supply chain is becoming more and more important to customers. The supply chain is important because we're trying to make things more efficient today. We're trying to make things much more economical than what we've had in the past. And of course, a great deal of flexibility. So we'll go through the supply chain, and in that we will look at several of Roboze products, including some materials. So where can we help in the supply chain? We can help in many areas of the supply chain. We can help with the product itself. So at Roboze, we have machines which can help you design the product and manufacture the product. That product can give you customization, or we can give you customization of the product. So it's quite unique, or is limited to a few numbers of machines or products that we're going to do, up to many products that we can do. We can integrate the functionalities and make things much more efficient than they've been in the past. And of course, we can respond very, very quickly to the market needs. So as the market changes, having 3D printers allows you to respond to those needs. Then in the production side, we can do mass customization. So rather than someone making a product and they've got to keep it in production for a long time, or they've got to keep the production the same to make it cost effective, we can help by making mass customization and making it easier and a more unique product for your customers. Then if we look on to the warehouse and the distribution, warehouse costs a great deal of money today. And of course, that warehouse is tied up with stock. We can reduce the lead time so that you don't only have that stock, but you can actually get a product in a more efficient manner than having it stored maybe on site or maybe quite a distance from your site. So we can certainly help with the distribution costs. And then of course, there's the one which is maintenance. If you have a factory and you've got a production line going, you may want to have printers that can produce parts as you need them. So those parts could be used in the production process, or there could be special tools that you use in the production space. This is very much becoming more and more important if you're in aerospace, automotive, and other large factories where you can respond to the needs that you need locally rather than sending out for something. So it's certainly a big consideration, the maintenance. We go on to the next slide and we look at the profit of the innovational focus. So you can innovate and profit from that innovation. You're not being restricted with what you've already got or what you would like to put into production, but you need large numbers. So innovation is a great thing, and innovation can certainly keep you ahead of your competition, and it can keep you at the forefront of your technology. As we said earlier, mass customization. The market is moving away from the need for one part which is going to last forever. People constantly want to make improvements. People want to advance their products, and you can do this with mass customization, albeit relatively low numbers of production. But of course, if you scale that over a number of years or a number of months, you're going to get more and more production. This is going to help you, and you get less choice and more customization. Reduce the cost of the warehouse and the logistics, very important. We're all trying to save fuel these days, trying to save emissions. And of course, if you don't have to transport to a warehouse, then from a warehouse, that saves in these costs as well. And of course, reduce the time to market. As we said, if you can innovate and make your technology or your products a way ahead of the competition, you will have a market lead on them. And that's very important. So the reduced time to market is becoming less and less. If you look at cars nowadays, they're produced in a relatively short time scale. And that time scale may be updating them on a regular basis, rather than producing a car and then having it there for 4 or 5 years because your costs are tied up on it. That is not the way to do it. Another example is mobile phones. Don't know about you, but to me, they seem to change every month. And that's what we can help with, reducing the time to get product to market. If we do a quick comparison between both of the traditional traditional manufacturing and additive manufacturing. Traditional manufacturing, which has been around for many, many, many years now, is focused on mass production. Long production runs, keep things in production as long as possible, because that's where you're going to make your money. The aesthetics are the same. The economies of scale are geared to make many, many products and not necessarily upgrade those products or limited upgrade to those products. With additive manufacturing, it's the total opposite. Your speed to market is much, much less. You can innovate and make new products and customize products in a very short space of time. You can also make sure, as we said before, that you're leading the market that you're in. So that helps your company, helps your costs. Complexity for free. You can make parts very, very complex. Parts that you would normally maybe manufacture in several pieces and put them into an assembly, you may be able to print that as one piece. And that complexity is there with 3D printers. You can print for that complex parts. That means less stocking of parts, and it also means that you can advance technology very, very quickly and take advantage of it. And manufacturing, of course, at the point of use. So that saves logistics. If you can manufacture where you need it, rather than bringing in lots of components or lots of parts from different parts of the world, manufacturing can, at the point of use, is another time-saving and cost-saving effect. Then if we look at the cost of what's being done here, in this slide here, we have thousands of parts. The traditional manufacturing needs thousands of parts to be produced. And that cost starts very, very high if you only produce a few of those parts. You've got to gear your manufacturing for the tooling. You've got to make some special components or some special parts that will help you make those parts. Those are expensive in the very early days. So if you're making something that's maybe, say, 250 parts, 500 parts, that parts become very expensive. And as we said earlier, what we're trying to do is drive that down, and with traditional manufacturing, you push that away out to tens of thousands of parts to make it cost effective. 3D printing is different. 3D printing, well, whether you produce one part or you produce 1,000 parts or 10,000 parts, your costs are going to be fixed. You're fixed because your material cost is fixed and your time is fixed. So it's much more flexible in your manufacturing process to have 3D printers that are, rather than gear yourself up to have many, many parts which are only going to be the same. Halfway through this cycle of maybe, say, 1,000 parts or 1,500 parts, if we wanted to incorporate changes, it's very easy to do that with 3D printing. With traditional manufacturing, your costs escalate again, and then you've got to write that out over a long period of time again. This is a very simple chart. It looks complicated, but it's actually quite simple. And it shows you what each of those costs are, whether it be production costs, the transportation costs, the inventory costs that you're holding, the inventory costs you're holding which you don't really need, or you don't know when you'll need them. This out of stock, if you have a part which is very, very popular and runs out of stock, and you've got to wait until you can restock from your suppliers. And all those costs add up significantly.
Sorry, everyone. Graham, I'm not so sure if you can hear me, but we do not hear you anymore.
On our products. PEEK is a very tough material. It's got a high, strong resistance to high temperatures. It's got a strong resistance to chemicals. So it's used for the product, or it could be used for jigs, tools, fixtures, making the products that you need. If you look at, if you did it on a CNC machine, you could preparation for 1 hour, 3 hours for production, and it's 3 hours to do it on a printer. So you've saved 25% straight away. If you look at the costs, because traditional manufacturing takes a block of material and machines that away with a high amount of waste, there is a lot of waste. With printing, you only use the parts that you need. You use the material to print in the areas that you need. Another saving in cost. Setting up a 3D printer is very easy. So the FTE time needed to set up a printer is very, very simple. It's automated. We automatically feed the material into the machine. We automatically set the build plates these days. Everything is very much more automated than it's been in the past. With CNC, they're still doing the same process they have done forever. And then there's the amount of waste materials. As we said earlier, if you're machining away, subtractive manufacturing, that gives you a high amount of waste. That's not the case with 3D printing. With 3D printing, almost everything is what you need to be printed with. So you can see here, there is big savings to use 3D printers, and particularly 3D printers which have materials which are very functional and usable for the applications that you need. This is a typical part in production. If you imagine you have several operators and they're all doing different processes. You could be cutting the parts, cutting material, you could be CNCing them, you could be welding them, more and more bringing things together. Those are manually or those are skilled jobs in some of those, but they're very, very labor intensive. Even today in manufacturing, with robotics, we're still getting fairly labor intensive in some parts of that process of making something. It is much easier if you do it with additive manufacturing. You have an operator, you have a filament that goes into the process, you have the 3D printer that's part of the process, and you have a final product. Much, much simpler, much, much easier, and reduces your costs significantly. If we look at some of the departments or some of the ways that 3D printing can help, if you have departments, you have cost and time reduction within those departments, you have less outsourcing to do, you have more control over your own supply chain rather than relying on others to deliver components or deliver product to you. You're less dependent on other people's schedule. If someone has an urgent job, your job may slip slightly, then you're waiting for something to come in to help you with production. And of course, production is only one point. You're doing that on your 3D printer. Because you're using your 3D printer and printing with your 3D printer, you have brought all those into the one location. Time costs money. There is no doubt about it. Time and money go together. If you can reduce the time, you will save money. There is less chance if it's an automated system than any human error. Human error costs time and can be very, very expensive. You can have productivity which continues even when no one is in the office. Your printer can be working away day and night. You load it up to do the parts that you want to do, and as you load it up to do those parts, you walk away and you leave it. The printers are reliable. They allow you to carry on with your other things that's got to be done. And when it's finished, you go along and pick up the parts that you require. It's a repeatable process. If you change the design that you're working with and you're trying to do something slightly different, still the same process for the printer. The printer will take the data, produce the part, and you have a part at the end. So if you've modified your design, that's okay, because it makes no big difference to the printer whatsoever. Waste reduction. In the world, we do waste a lot of material. We waste a lot of material that maybe we should not do so. We are quite a wasteful society, I've got to confess. But if we can cut down on that material, that is great. That is great because if instead of doing this subtractive manufacturing where there can be a high volume of waste, if you do additive, you're only using the material that you really need. So that can be significant. I have seen parts which have been 80% has been waste because it was a relatively small part or a relatively thin part that was needed, and that meant that 80% of what they were machining was straight into the bin or had to be recycled, which also costs money. Parts can be lighter. With some of the technologies we have today, or the materials that we have today, we can produce parts which are as strong as metal. Phil referred to this in his earlier presentation, and it's very true. You have parts which are lighter, which means that if it's fitted to some transport system, whether it be automotive, whether it be aerospace, it reduces the weight of that vehicle or that aircraft. That saves emissions. If that saves emissions, that helps to save the environment. And of course, as we said earlier, many parts are used to build an assembly. That becomes very, very time consuming. That becomes very much that you can't change one part without modifying something else. With 3D printing, the complexity of the geometry doesn't matter. The printer will print it and it doesn't really care. I've seen case studies where if you take an assembly of parts, 10, 12, 20 parts, and you could print that as a single part on a 3D printer. That saves a lot of time in your manufacturing process. And this is not an exceptional case. This can be fairly standard where you can reduce time and reduce effort and make them into a single part as opposed to something which is going to be assembled. This does mean that you need to look at 3D printing slightly different to how you've done it in the past, but guess what? We're all there to help you get that and make the efficiencies in what you're trying to do. Human resource optimization. You can have lean number of people. You can have a production chain which is much, much leaner and needs fewer people in it. This leads to a reduction in the human resources that you need. And that doesn't mean that everyone has gone. What it means is that people could be doing something different to standing next to a machine. 3D printing is reliable enough and doesn't need adjusted in the process. You start the printer, you come back to the printer at the end. You don't have to keep an eye on what is happening within the printer. You don't have to watch the printer and make adjustments as you go through. Basically, what you do is you load up the job, you start it, you leave it, and meantime, you can be doing other things. You can be modifying designs, you can be preparing for the next jobs, you can be scheduling. There's so much more that can be done rather than watching a machine. And then assembly. So assembly, you're eliminating the complexity. You're making it easy to assemble. We have parts which you can use very, very effectively in part of holding to make sure you can make this assembly. If you imagine you had some metal parts and you had to join them together, and you want to do that accurately, or you want to do that with a little bit of heat involved to make sure the parts bond together, we can provide you materials that will allow you to do that. This helps in the accuracy of your assembly. This helps in the customizing tools which fit exactly what you need. You don't always have to use standard products. You can use products which are very, very customized to your needs. And that's very, very important. That gives you control. That gives you the ability to make those unique for yourself rather than buying something off the shelf. With traditional manufacturing, as we know, we are shipping things all over the world. You know, we have many countries involved. Many countries are providing part of the components that we need. High volumes, low cost, this is what we go back to. So they're shipping it all over the place. It is not always the most cost-effective way to do it. Transport costs are high, transport costs keep rising, and we need to think a little bit more of how we do this. If something happens and you're waiting for components from across the world and something goes wrong with just one of those components, you're going to hold back your production. You're going to hold back your production, which means that you cannot get output. If you cannot get output, you cannot invoice, you cannot get the assembly going. So very much we need to try and reduce some of this travel, not just for ourselves, but for the emissions as well, for the world, and let's try and make the world a more healthier place to be, should I say. With additive manufacturing, the design could be produced in one country. The design is easy to transport to another country because, for example, in Germany, if you are making some design for cars, aerospace, machinery, whatever, those data fields, those software, the CAD software, the files from there can very easily be sent to another part of the country or another country. It's very, very easy to do that. We have the cloud and we send it via cloud nowadays or some other method. So we're not using transport systems, we're using the internet system to do that. The raw materials could come from another country as well. And we send in raw materials. Those raw materials could be filaments. And those are fairly easy to ship. They're very easy to ship, to be honest. And you could ship those in, all coming into one to make the product. And it doesn't matter whether it's across a country or whether it's across a single country. Both can be much more efficient than what we're used to in the past. The costs are fixed and it's easier for us to keep control of the customer and the manufacturer. It's much, much easier to do that than it coming from many, many different sources across the world. Here's a typical case study. So the vehicle trucks, a customer that we have down in Italy, in our home country, that you see on the right-hand side, there's a sliding stopper made in PEEK. PEEK is a strong enough material that can be used as a produced part. It can be used in situ in this truck. So when the door slides, that is a stopper there for the door. This has saved them a time of about 90% in supply time and costs, a significant difference with just one single part. After they did this, they then looked at other parts of where they could save money and where they could save time with the production, and that increased everything a great deal. It doesn't mean we're producing the whole vehicle, but we're contributing to make the vehicle in a very significant way. And all those little times that we save with components all build up, of course, and make it much, much more efficient. A PEEK valve for an oil and gas sector. This is a valve that's used within the oil and gas sector. Sorry about the phone, just give me 1 second. Apologise for that, I've just disconnected it. So this is a component that's needed, fairly common in the oil and gas sectors. There is a lot of waste and a lot of money in the oil and gas sector. You know, there is if you stop production, whether it be in a car factory or whether it be in oil and gas, it costs you an awful lot of money. The time to produce this part was about 4 hours. And as I said, we have parts that are materials that can be used to make parts which are excellent chemical resistance. This is what they required. This would be a specialist part. And this part, if they had to wait for someone to manufacture it, it would cost a lot on time. They've got to wait for it to come in-house. Equally, if they have a warehouse full of those and many, many parts in stock, it's costing them money. We could produce this part in a few hours. And this is a real functional part that they can use in day-to-day life of producing oil and gas. Also, sorry, one thing I missed there was the resistance to high temperature. This part here could resist temperatures up to 245 degrees centigrade, which is a great step on where we were a few years ago. Warehouses, we drive down the motorways these days, or the Autobahn, there is many warehouses. Many warehouses not just holding final product, but also holding parts for people. These warehouses cost a lot of money. And also, it's stock. This stock costs a lot of money. It ties up your cash. Why not print it when you need it rather than having a warehouse full of parts? You still have the same problem with a warehouse in that you may be hundreds of kilometers from that warehouse and they've got to transport it to you. Why not have a printer close to where it's needed and print the part as you need it? Or you have got routine or scheduled maintenance, print those parts before you start your routine maintenance or your scheduled maintenance. And those can be on your office right next to where they're required. Warehouse costs, we've already touched a little bit on. The capital costs, the storage costs, service costs, risk costs. If you have a warehouse full of components, you're very reluctant to change your design because you're going to have to write that cost off or part of that cost off. You don't really want to be changing a design and then having to get rid of some of those components that are sitting there and they're dead components. Basically, the warehouse is going to cost you a lot of money. If we look at this slide here, we see there's a physical warehouse, mass production. As we said earlier, we're producing many components and then stocking them. If you look at just-in-time manufacturing, it's a similar process. You're trying to produce them or trying to get them into the car factory just in time, but there is still a large stock because you cannot afford for that to go down. You cannot afford to not be supplying to your customers. Stocks always exceed your needs because you need to have a buffer in there. This obviously increases delivery times as well. With a digital warehouse, you have all the data online. The data is available for you when you need that data. So you're not overproducing parts and you're taking stock from when you need the parts. This becomes much more cost effective and much more reliable than you've had in the past. You don't have the big inventory costs that you've had in the past. And of course, you're delivering the parts right to where you need, which of course is at your office. And as we keep talking about, it does reduce your carbon footprint. And this is a good thing for us going forward, that we all try and save and reduce our carbon footprint. If we look at this here, how to optimize the warehouse costs, we have a catalogue, a spare parts catalogue or a product catalogue, and you can decide which parts are the ones which are going to move slowly or which ones are going to move quickly. What do you need? Here's a part which we very seldom need. You do not want to stock that part. You want to produce that part as you need it. Even for a slow or a very slow component, don't tie up with many components there off the shelf which are costing money to stock. Have those components produced as you need them. We don't do everything. There is some parts that will be needed constantly, maybe an hourly or a daily basis. Yes, those can still be done with traditional manufacturing. Okay. The whole idea is to have the parts when you need it, as you need it, and save on the long drawn out way of producing parts and stocking those parts. So what can Roboze do to help you with your 3D printing? We have a wide range of materials. We have a wide range of machines. We also have a service called 3D Parts, which is like an on-demand, just-in-time production site. This is done with a group of, or a network of companies that we deal with across the world. And basically, it's another way to get into 3D printing to prove that it's right for you. It's close to where you are, closer than shipping across the world, but it is close to where you are and it gives you a taste of what can be done. Our printers themselves, we have, as you've seen on Phil's chart, low-cost printers right up to full production printers. Printers which are desktop printers to production range. So we have a wide range of printers that we can help and analyze what you need. And that's part of Phil's job, my job. All of our job is to analyze what you need so we get the right solution for you. So just looking quickly at Roboze 3D printers, faster production than traditional methods. You get it on demand. You get it when you need it. One-step production. There is not a number of people producing or a number of operators producing the parts. You can have one person operate the machine and they control the machine. So that is good. Reduction of material costs. You're saving material. What you're not doing is you're not making stock, and you're not subtractive manufacturing with a high amount of waste. So your reduction in material costs is significant. Reduction in labor costs. Reduction in risk and planning times. You get the components and the parts when you need them. You're not relying on someone else. You have control and you can do that. Your independence from external suppliers is reduced. You do this in-house. And of course, creative of freedom. Freedom to make parts as you need them. Freedom to modify and update and enhance your products and the technology you're using as you go forward. So very much we are giving you something that you can do and make sure that 3D printers are an ideal fit for you. 3D parts, as we said, is a flexible manufacturing system of high performance parts. We use products, or we use materials which are high performing materials. It's what Roboze is known for. They're known for producing parts or producing materials which are very, very unique and strong. Whether that be for high temperature applications, whether it be for high strength applications or high chemical resistant applications, we have them all. And 3D parts, Roboze 3D parts, can give you a flavor into that. You can use them to buy some of those parts, to try those parts and test them for yourself, and then work up to a reasonable sense to what you need for your production. Do you need a large machine, small machine, big platform, small platform? You can find all that out by using us to produce some parts. That is not a problem. Some of the customers we have already sold machines to and are using our machines. This is just a small amount of the people that we have. There is many, many well-known customers from across the world that we do. For each well-known customer, there is many so unknown customers, customers who work away, who supply those companies as well. Airbus doesn't do everything. Airbus uses many of the suppliers to use to print parts for them. We have the companies that provide the parts to Airbus. Okay, so I'm going to hand back to Phil. I would encourage you to talk to Phil, talk to myself. We're there as a consultancy service. We don't just want to sell you a machine. What we want to do is sell you a solution that fits with your business best. So by all means, contact us, talk to us. Roboze 3D model. We do have a very strong partnership and we want to give you the best service that we possibly can. With that, I'll hand back to Phil and Phil will pick up from there. Thank you for listening, and if you have any specific questions, please contact us.
Thank you very much, Graham, for the excellent presentation. While we wait for some questions to roll in, I wish to show some parts live, if the people don't mind. So I'm just going to share my camera here. So these are just some selected parts in selected material. So I'll just bring the first one up. This is now a part, also a valve that is printed in PEEK material. Yeah. What is also interesting from the Roboze side is they not only have pure PEEK as we've seen here, but also a carbon PEEK material. It's a very, very strong material. I would say as strong as metal. Even if I try to close the gap here, very tough. I can hardly budge it. 3D model, we've also been doing our part for the COVID-19. We've been doing, developing the handles, right, for the doors, so we don't have to use your hands. You can just use your elbow. This is clamped in on the door, and this is a carbon PA material. Yeah. And the last part that I also want to show is, this is also for the automotive industry. Maybe I have to put this a little bit farther away, right? For e-racing, right? These are combination parts to attach the wings. Yeah. So I see now that some questions have come in, and I will go through them as well. So Graham, I take it you're also still there?
Yeah, still here, Phil. I had gone on to mute, but I'm back in again.
Okay.
So I can help with questions, no problem.
Okay. I do see a question of what are all the different materials that Roboze offers. Just chime in, Graham, if I leave something out. Okay. As said, we have a PEEK, we have carbon PEEK, we have a carbon PA. We also have a functional nylon, as well as we have standard plastics like PLA, ABS. We also have, as well as a PP material. Yeah.
I think that covers most of them, Phil. In total, we have about 12, 14 different materials depending on the machine that you're going to use. We do have a new one which is actually exclusive to us for 3D printing, is X-Steam. X-Steam is a very popular material in the aerospace industry, and we have done a partnership with Selway, who manufacture it, and we have an exclusive on that for the next few years coming. Obviously, they're supplying into the aerospace industry already in a subtractive form, and we are the first ones to use this on a printed form for them. So yes, we do have, as I say, a wide range of materials, and I think Phil has covered the most of them. There's glass PA as well, and a few other ones. There's a flex material, a TPU material as well. So yes, we do have a broad range of materials.
Second question that we have is, due to the chemical resistance about PEEK in combination with the heat resistance, is a reason why we're using PEEK in the pharmaceutical industry. In the 3D printing sector, we're struggling with the regulations. Is there a food grade certificate, FDA, available for some of the Roboze materials? Graham, I think you're going to have to help me with that one.
Yeah, no, I can take that one. That's not a problem. We don't have a food grade material today. To be honest, it's something that we do visit and we do look into. To get food grade materials takes a long time. And it's not so much the material, it's more the testing of it. It's, as I say, it's something we do come back to on a regular basis. So we don't have that today. So we cannot, our products cannot be touching the food. But of course, there is applications behind there where we can be using it. So, you know, if as you make the food, for example, and you put that food into a container, we can certainly help with moving containers and such like. The actual contact of food is something that we cannot do today.
Maybe just to elaborate as well, just there's also the possibility with the Roboze machines. It is also an open system, and therefore it is also possible to use third-party materials if needed. Yeah.
Yeah, that's a good point, Phil.
Yeah. We have another question. Can you print parts like gears and use them to replace for original part? That would be the what would be the right material to use? Yeah. Yes, we can print gears, and the material that I would suggest definitely carbon PEEK and PEEK material. And depending on also on usage and how much stress is on the part, there is also a possibility to use carbon PA.
Yeah, that's right. I mean, we do produce, several companies do use it for machinery, or use those components for machinery, and they will print on a printer and then obviously fit that into the mechanism, whatever that mechanism is. And it's an ideal place where you have older machinery and you need components, and you need those components fairly quickly. We can certainly help with that.
Next question. Oil and gas industry is moving towards additive manufacturing with many initiatives. Therefore, the question concerns your position in this path and the certification of printed components. Yeah, I think, Graham, you have more experience or in this section.
So our materials like Ultim today that we have and we use is already certified. So certified for aerospace, but I'm sure if we know the certification that's needed, we can certainly check it out for you. And certification for oil and gas, I do mean. But yes, so more and gas is moving there, not just in the seals or in the first seal. There is many components coming together, pumps and such like coming together, and the seal between the pumps and the pipeline or whatever, you can actually print with PEEK. A lot of them PEEK seems to be the most popular material there, and not just the original seal, but obviously there is safety seals behind that as well. So there can be 2 or 3 seals together, so that if in the event of something going wrong, there is protection. And yes, we do this already. Oil companies that we can talk about are already doing this. One of them is Baker Hughes, and they have an Argo 500. They have that in Italy. So yes, we do have oil and gas, good applications in oil and gas.
Just we'll wait. Maybe another question will roll in. Again, feel free to contact us anytime, me or Graham. 3D model, again, we have 2 showrooms, again in Switzerland and 1 in South Germany. If you wish, we can always do a personal invitation, also from a video conference, if some of you are not able to, under these certain circumstances, to travel. It's not a problem. We can organize a Skype or a Zoom or even a WhatsApp video call. We can show machines. We are very happy to do a one-on-one consultation. So feel free to contact us any time. Yeah. So if there is no further questions, then I will say thank you very much, everyone, for participating. Again, thank you very much, Graham, for taking the time and for the excellent presentation. And this webinar is recorded, so it will be also later on posted. So again, stay safe, everyone, and have a nice afternoon. Bye, everyone.
Thank you as well for attending, and yes, I hope to speak to you all soon. Thank you. Bye-bye.